Hello everyone. So here I come with another session of HCU questions. Okay. So which are based on general organic chemistry and electronic displacements. So here in this session I'm going to cover 2016 and 17 questions which are came in the HCU examination for PG Entrance Chemistry. Okay. So let's talk about the first question. So it is about the boiling point. Okay. So boiling point of isomeric hexanes. So generally boiling point which is of the hydrocarbons is proportional to the surface area. Okay, surface area. So if the surface area is more, it means if it is a linear, okay, if it is linear, more linear, so its surface area will be more, so that the interaction between the molecules can be easily attained, so that one atom can be easily attached to the other atom and the other can to with the other atom so that they can form like a sheet. Okay, so they can form like a bunch, so which will increase the requirement of energy, which is not nothing but temperature. Okay, so that the boiling point or boiling temperature requirement will be more. Okay, so the boiling point will be more. So if it is more linear, it will be more boiling. So highest boiling will be this one. So increasing order it is asked. So one will be at the end. So these are the two options with one highest. Okay. So next, less branched. Okay, less branched or more linear is second. Okay. Next, among 3 and 4, 3 is having more branching when compared to 4. So it is 4 then 1. So correct option is 1. Okay. Here the logic is surface area. Boiling point proportional to the surface area. Okay. So let's look into the next question. So here it is a question about the IUPAC name. Okay. So it is a vinyl group and this is methyl. Okay. So generally, for cyclic compounds, it must be clockwise numbering. So I must start with the olefin. So 1, 2, 3, 4, 5. Okay. So it is 1 methyl and 5 vinyl, cyclopent 1 in. Okay. So option C is correct. Based on the all rules of the IUPAC, which are methyl and vinyl. So M should come first according to alphabetical order, and numbering wise for cyclic compounds it must be clockwise, and olefin must be taken as a more priority which is present in the ring. Okay, so based on all these rules it is given that C is the correct option. Okay, so next, most electrophilic molecule among the following. So generally electrophiles must have the empty orbital or with the positive charge. Okay, these are the species which are having electrophilic nature. Okay, electrophilic nature. So if it is a nucleophile, it must have lone pairs, for example NH3. Okay, or it must have the unsaturation or pi electrons, for example ethylene. Okay, so among these four, H2O is having the lone pair which acts as a nucleophile, and ethene can act as a nucleophile because of the pi electrons, and NH3 can act as a nucleophile because of the lone pair. So the one which is not nucleophile is BF3. This is having less octet configuration or deficiency from the octet, because if it is BF3, it is boron, which is third group element, which is having 3 electrons. While it is forming the molecule with the fluorine, it's going to share 1 electron with the 1 fluorine. So each, so the total electrons of this molecule are just 6 electrons. So according to octet rule, the molecule which is having 8 electrons around its central atom will be stable. So it is less than the stable octet configuration. So it needs electron. So the species which requires electron or which is readily towards the electron density, that is electrophile. Okay, so which is nothing but electron lover. So this is what electrophile. Okay, let's go to the next question. So here is another question about the IUPAC Indian. So given the double bond and triple bond, okay, and alcohol is also present, okay. So here I need to follow the least sum rule. So if I start from this 1, 2, 3, 4, 5, and 6, okay. So it is first position substituent is there, and second position the triple bond is there, and fourth position substituent is there, and fifth position double bond is there. 1 plus 2 it is 5, 3 plus 4 7 plus 5 12. So if I give a number from this 1 2 3 4 5 and 6, okay. So 1 3 4 and 6. So 1 plus 3 it is 4, and 3 plus 4, sorry, 4 plus 4 8, and 6 it is also 12, okay. So according to least sum rule it is one and the same, okay. So look into the uh, OH, okay, it must be suffix among all these high priority group. So it must be least prioritized, so it is one all, okay. So I need to take the numbering from this set, okay. So rest all are same, only numbering is the confusion, numbering is the logic here, okay. So it is 4 methyl, okay, and hexyl system. So hex first ene, then ine, enine systems, okay. In the last session also I told enines it will be called. So ene will be first suffix, then ine, okay. So hex 5 ene and 2 ine 1 all. So option A is correct, okay. So let's go to the next question. So decreasing order of the acidity. So it is asked for the acidity. So which were asked in 2017. Basically conjugated acids. Conjugated acids are more acidic when compared to non-conjugated. Okay. Conjugated acids are more acidic when compared to non-conjugated. Because when it is conjugated, the carboxylate anion will be more stabilized. Okay, more stabilized with the conjugation compared to the non-conjugated systems, okay. So here conjugated are these two, and moreover these are sp3 carbons. Inductively these are sp3 carbons, and this is sp2 carbons, and this is sp carbon. So sp carbon can withdraw more electrons, which will stabilize the anion more efficiently when compared to sp2 and sp, okay. So here mesomeric effect is also not required, just with the simple inductive effect you can reflect the answer. So sp carbons are more electron withdrawing, so it's a good withdrawing group, so that it can stabilize the anion, the carboxylate ion, which is forming by the proton donation, okay. So 4, then 3, and after this the acidity of the 2 and 1, okay. After this the acidity of 2 and 1 will be more acidic when compared to 2, because it is steric, which cannot donate the electron density much efficiently than compared to the 2, okay. So the correct answer will be option 2, option C, okay. Next, this is the one of the tricky question and very important. So you've been given C3H6O formula and asking for the structural isomers are possible, the number of structural isomers. So let's start trial and error method. So you need to draw the structural isomers. So it is degree of unsaturation is 1, so it must have one ring, okay. So all 4 atoms I have taken. So this is one example. CH2, CH2, CH2. So C3H6 and O, okay. So when I'm removing this oxygen from the cyclic system, so it is this. and this is another example. Okay, so if I take one of the carbon outside, so that will be this one. Okay, so these are the three possibilities. So is it okay that maximum number will be 3? Of course not. The maximum number will be 4. So what could be the fourth one? So if you want to write the fourth one, pause the video and try to think for a 5 minutes and try to write the fourth one. Okay, so by pausing the video. Okay, after your workout, restart this, resume this video. Okay, so here I am giving the fourth possibility, that it is the enantiomer of this compound, because this carbon is a chiral carbon. Okay, because it is having four different groups. Okay, four different groups, so it is a chiral carbon. So another will be its mirror image. So this is what the fourth one. Okay, so 1 2 3 and 4. It is very tricky and very important question. So whenever you come across the questions like this, try to think maximum possible isomers, otherwise your answer will be going to wrong. Okay, so maximum possibility. Okay, that's about the isomers. Next, the increasing order of heat of combustion. So heat of combustion is directly proportional to the number of carbons. Okay, number of carbons, or you can also consider mass, E equal to mc square. So as the mass is more, the energy released will be more. Okay, Einstein theorem. So in simple ways also you can see, if you require more flame, what you are going to do? You require more fuel. Okay, so you're going to burn more wood. Okay, so that you can get more amount of heat or more amount of flame. Okay, so that is what. So number of carbons here, 8. Here also 8. Here 7. So among these three, these two will be maximum. Then this is least. So 3 will be the least. And among this, if it is linear, okay, if it is linear, it's going to have more energy when compared to non-linear. Okay, when compared to non-linear. So highest energy will be with 1. Okay, and second highest will be with 2. Okay, so if it is linear, it's going to have more heat of combustion. Okay, so if it is non-linear, it will be less heat of combustion. So next, the electron rich olefin among the following. So this is olefin attached with oxygen, and this is olefin attached with C double bond war. This is methyls, two methyls, so which are donating, and this is bromine, which are withdrawing according to inductive effect. So minus I, and plus because it is having lone pair. Okay, you need to consider all the electron displacement effects. Okay, so three substitutions. So this is withdrawing. So this is minus I and minus M. So this is again donating and minus I. So plus M minus I. Okay. So among all these, the lone pair having compound which is with oxygen will be efficiently going to donate. So that will be most electron rich, and among these, least electron rich will be B. Okay, most will be A. Okay, because it is going to donate the electron density through mesomeric effect. Okay. Next, decreasing order of dipole moment of the dipole moment is made by the, if I say, the tetrahedral form of any compound. Okay. So in tetrahedral compound, if it is existing or exhibiting the dipole moment, means fluorine is going to pull the electron density towards this, and hydrogens cannot pull or cannot release the electron density. So the electron density will be towards this. Okay. So movement of the electron density towards one side is called dipole moment. Okay. Movement of the electron density towards one side is called dipole moment. Okay. So this is about one atom which is withdrawing. Here it is given two atoms. Okay. So then also it will be a kind of system like this. So fluorine, and the first one is CF2Cl2, and second one CF2H2, and third one is CCl2H2. Okay, among this I am taking CF2H2. Okay, so electrons are pulled towards the fluorines, so the electron density will be towards this side. Okay, one side. Okay, so if it is fluorine and chlorine, then if I compare, chlorine can pull less efficiently because it is having less electron activity when compared to fluorine. So it will pull the electron density less compared to fluorine. So this will be the more when compared to this one. So 2 will be more than 3. Okay. So after this, if I replace the fluorine CF2Cl2 CF2H2 with CF2Cl2, so hydrogens are replaced. So earlier there was no opposing force to the fluorine, but when I place the chlorine, this will withdraw the electron density towards this side, and this will withdraw electron density towards this side. So now dipole moment means being one side but not being all the sides. So when all the sides are pulling, the dipole moment will not be at any side, so it will be less towards the fluorine because fluorines are little bit more withdrawing when compared to chlorine. So when it is chlorine and when it is fluorine, it is easily one-sided. But when it is fluorine and chlorine together, it is no side. So it will be in between. So least dipole moment will be with 1. So correct option will be 2, 3, 1. Okay. So option B. Okay. So next, one more question. So here the major product. So it's not major products. So these are in what intermediates. But let's go with the options. Okay. So when H plus is exposed to the base, so why I am calling base, because it is having nitrogen with lone pair. So this can be Lewis base. So or you can consider as a nucleophile. This is what electrophile. So among these two, which could be a better nucleophile? So the nucleophile which is non-conjugated will be better nucleophile. So here it will be in the conjugation. It is like aniline system. Okay. So anilines are less basic when compared to the secondary amines, which are non-conjugated. So this will be more basic or more nucleophilic. So it will be going to attack, resulting what? Resulting into B, option B. So so already H is present, and it's going to donate the lone pair and abstract the H. So this becomes less. So option B is correct. Okay. So after this, if I get heated, okay, it's going to break up the NH2. Okay. So break up the NH2 and it's going to form the olefin type systems. Okay. If it is co-elimination type reactions. Okay. So till this is the answer. Okay. So next. So the last one from the HCU previous questions. So decreasing order of the basicity. So basicity of anilines with plus I groups increases and with minus I groups decreases. So these all are with minus I groups. So highest basic will be 1. Okay. So after this, when it is NO2, it is minus I and minus M. So minus I and minus M groups should be at meta position so that they will support the electron density. Otherwise, if they are ortho and para, they will decrease the electron density at ortho and para positions. So it will not able to donate. So meta will be next one, and along the ortho and para, according to minus I effect, it should be far away so that electron density quenching will be less. So withdrawing nature will be less. So fourth para will be more than 2. Okay, ortho. So this is the basicity order: highest and second highest, third and fourth. Okay. So that's all about the HCU previous questions. So from this topic, okay, it's not over. From this topic, these are the questions that I gathered. So you will be going to get more updates and more previous questions explanations, and the detailed discussion of the types of reaction is going on every day. So you can subscribe and you can join the live classes. So be in touch and be watch. Okay, thank you.